So today we're going to actually begin talking about this idea of an antiderivative of a function. The bulk of what we've talked about prior to Unit 5 has been about limits and derivatives. And so today we shift gears and we begin looking at this idea of an antiderivative. And so the antiderivative of a function, f of x, is denoted by, this is an integral symbol. Looks like a music note to me. However, this is a symbol that represents an integral. And this says the integral of f of x dx. When we find the antiderivative of a function, we're finding the function for which f of x is the first derivative. So this will enable us, if given f prime or even f double prime, to be able to find the original function. So we're just going to go ahead and jump right into this. So this is find each of the following antiderivatives. So we have the integral of 3x squared plus 2x plus 3 dx. This is wanting us, or indicating for us, to find the antiderivative of this function. And this function is representative of the derivative. So this is simply a polynomial function. So its derivative, if this is the derivative, then, well, if I were going to ask you to actually find the derivative of a polynomial function, you would do the power rule. And so to find its antiderivative, we're just going to kind of reverse the process for the power rule. So take a look at 3x squared plus 2x plus 3 dx. Focusing on the first term, I'm going to take the power of 2 and I'm going to add 1 to it. So it's 3 times x to the third. Now I'm going to divide by the new power. So I have 3x to the third over 3. And then I'll do the same thing with the 2x. And so that's positive 2. Multiply that by x squared over 2. And then for 3, that would be 3x to the first over 1. When I clean this up, this simply turns out to be x cubed plus x squared plus 3x. Now, how do you suppose we could check ourselves? Well, if this is supposed to be the function and this is the derivative, then all we have to do to check is to take the derivative of this and see if we get what we started with. So the derivative of x to the third would be 3x squared plus 2x plus the derivative of this term would be 3. Now, the one thing that we need to talk about is this is what we call an indefinite integral. And the reason why is because this particular function, derivative has more than just one function that would be considered the antiderivative. Because if this function had, let's say, another number added to it, we'll call it c, then this would be representing an infinite number of functions for which 3x squared plus 2x plus 3 is the derivative. And so these are the types of integrals that we're going to be working with right now. Eventually, we will take a look at, okay, well, is there one particular function that would satisfy a particular integral? And the answer is yes, but we'll get to that shortly. Okay, so now let's take a look at this example. On this example, I would probably recommend this integral could be rewritten to where finding the antiderivative would be a little easier. And that would be this. The antiderivative, or the integral of x cubed over x plus the integral 2x over x minus the integral of 4 over x. And what I've left off on each of those is my little dx. Okay, so this is a property that is that can be used with integrals or with a polynomial divided by another function. So if I clean this up a little bit, I can find the derivative, not the derivative, the antiderivative of x squared dx plus 2dx. Now, the 4 over x, I'm actually going to rewrite this as, I'm going to actually leave this as, I'm going to pull the 4 out, and then I'm going to write this as 1 over x dx. So what I've done is I've just really separated the numerator here over the denominator into 3 separate integrals. This step where you're, let me do this. This step here where we're putting the integral symbols, really, I mean, this is really not necessary if you bypass this step. So here's what I have. X squared dx becomes x cubed over 3 plus the 2 dx becomes 2x over 1, which is just 2x. Now I want you to think back to 1 over x. 1 over x is the derivative of a particular function, and that is the natural log of x. So right now I have x to the third over 3 plus 2x minus 4 times the natural log of x. And because this is not the only function that would have this as its derivative, I'm going to add c. And we typically will call that the constant of integration. So cleaning this up just a little bit more, x to the third over 3 plus 2x minus 4 times the natural log of x plus c. And so here is the antiderivative of this function. Okay, now on our next example, I would suggest let's go ahead and multiply this together, these two binomials together, because that will help us find the antiderivative a little easier. So if I distribute FOIL, I get 2x squared minus 3x plus 4x is going to be plus 4, nope, I lied, plus x minus 6 dx. So multiplying these two together, 2x squared plus x minus 6 dx. And now for the antiderivative, this is a polynomial. We will just reverse the power rule. So that would be 2x cubed over 3 plus x squared over 2 minus 6x, and then we will add, well, I don't know why I put 1, but that should be a plus c. So here is a family of functions whose derivative would be 2x squared plus x minus 6, which then could also be represented as the product of x plus 2 times 2x minus 3. All right, then for this next example, I would probably rewrite this where it's a little easier to work with, I would take the square root of x, which is x to the 1/2, and I would even bring it to the numerator. And so really what I'm looking at and working with is 2x to the negative 1/2 power dx. So now finding the antiderivative of this function is a little easier. We're going to reverse the power rule. So I have 2, okay, add 1 to the power of negative 1/2, so that's negative 1/2 plus 2 over 2, which gives me 1 over 2, and then I have to divide by the new power of 1/2, but don't forget that dividing by, dividing by 1/2 is the same thing as multiplying by 2. So I'll take the 2, multiply it by the 2 that's already there, and I have, excuse me, 4x to the 1/2 power, and we need to add the constant of integration, the plus c. So don't forget, you have a way of determining whether your antiderivative is correct or not. If I come over here to check, then the derivative of 4x to the 1/2, remember you take the power, 4 times 1/2, subtract 1 from the power, which gives you negative 1/2. And when you clean this up, you get 2x to the negative 1/2, and then you can write it as 2 over x to the positive 1/2, which does turn out to be 2 over the square root of x. Okay? So now let's just remember that when you are finding antiderivatives, you can always check your answer or check your function by simply finding the derivative of that function and see if you get what you started with. The symbol, this is an integral symbol, which indicates for us to find the antiderivative of whatever that function is. All right, a couple of things to remember. Remember that the derivative of sine of x, do you recall what the derivative of sine of x is? The derivative of sine of x is cosine of x. So if the derivative of sine of x is cosine of x, then what do you suppose is the antiderivative of cosine of x? Well, what function is cosine the derivative of? And that would be sine. So the derivative of sine of x is cosine of x. Therefore, the antiderivative of cosine of x is going to be sine of x. Okay, and if we recall that the derivative of cosine is the opposite or negative sine of x, then what is going to be the antiderivative of sine of dx or sine dx? Well, you have to incorporate the sine, S-I-G-N, of sine, and since the antiderivative of sine is cosine of x, it's truly going to be the opposite of sine of x. Or actually, sorry, let me rephrase that. The antiderivative of sine of x dx is negative cosine of x. If you think about taking the derivative of this, what is the derivative of cosine? The derivative of cosine is negative sine. So the derivative of negative cosine would be positive sine. Okay? All right, so those are some things that are definitely needed to be known, that you need to know. So now let's give some practice to the trig functions, or expressions involving the trig functions. All right, so here we have the integral of 2 sine of x plus cosine of x dx. So just because this is two terms, just we could go ahead and find the antiderivative of 2 sine of x. So what is the what is the antiderivative of sine? Well, that's your negative cosine. So I have 2 times negative cosine of x plus, what's the antiderivative of sine? What's the antiderivative of cosine? And that is sine. So remember, what is the derivative? What is the derivative of sine? And that was cosine. What's the derivative of negative cosine? That's going to be positive sine. So now, adding my constant of integration and cleaning this up just a little bit, we get negative 2 cosine of x plus sine of x plus c. And this is the antiderivative of this function. Okay? All right, moving on to the next one. Change the variable a little bit, but that's not going to change the process. I have, this is asking us or indicating for us to find the antiderivative of t squared minus sine of t. And I don't know why that little plus sign is right there, so I'll get rid of it. So the antiderivative of t squared is going to be t cubed over 3 minus, okay, what's the antiderivative of sine? Well, the antiderivative of sine is going to be negative cosine, but the negative out front will make this positive. So that would be positive cosine of t plus c. So to check what's the derivative of this term, that would be 3 times t squared over 3, which gives us our t squared. And the derivative of cosine of t is negative sine of t, which gives us that right there, and then plus c. Okay? All right, and we'll do a couple more. What is the antiderivative of 4x? That would be 4x squared over 2 minus 3. What is the antiderivative of cosine? The antiderivative of cosine will be sine. So I have 4x squared over 2 minus 3 times sine of x, and then I need to add c. Now cleaning this up, that leaves me with 2x squared minus 3 sine of x plus c. And if I check to make sure, 2x squared becomes 4x. The derivative of sine is cosine, so that's 3 cosine, and we have the minus out front, and the derivative of the constant is 0. All right, and then for this example, I would recommend writing this first as x to the 1/2 dx plus sine of x dx. I'm not sure why I wrote it twice like that. You don't have to, but here we go. Treat this as the power rule. So that would be x to the, when you add 1 to 1/2, you get x to the 3/2. If you divide by 3/2, that's going to be the same as multiplying by 2/3. And then plus the antiderivative of sine of x is cosine of x. And that needs to be subtracting. The derivative of cosine is negative sine. So in order for us to have a plus sign there, that would have to be negative. And then plus c. So finding the antiderivative is basically finding the function whose derivative is given. Okay? So let's look at a couple of other scenarios. So pulling this back down, let's say we want to use this given information about f prime or f double prime to find the function that satisfies all three of these conditions. Okay, so what we know is we know that the second derivative is equal to 2. We know the first derivative evaluated at 2 is 5. And f of 2 then is going to be 10. So what we'll do is we start with the second derivative. And so the second derivative, f double prime of x, equals 2. Well, what can I do to find the first derivative? Well, find the antiderivative or integrate both sides of this equation. Well, what is the antiderivative of f double prime of x? That would be f prime of x equals, what's the antiderivative of 2? That's going to be 2x. And because there's an infinite number of functions for which the second derivative equals 2, we will add our constant of integration, which is plus c. So now let's talk about what we know about the first derivative. We know that the first derivative evaluated at 2 is 5. So what if I replace x with 2 and f prime of 2 with 5? That's going to look like this. 5 equals 2 times 2 plus c. So what do you notice? Well, when the derivative is evaluated at 2, the result is 5. And by doing this, or substituting those values, this allows me to determine that the c value for the first derivative is 1. So now we have a specific first derivative, f of x equals 2x plus 1. And this is the only first derivative that satisfies the fact that f double prime is x is 2 and f prime of 2 is 5. So this information was what we needed to be able to find the actual value for c. Okay, so now I can take this one step further. If I want to now find the original function, let's find the antiderivative of f prime of x, which we know will be f of x, and the antiderivative of 2x plus 1 will be 2x squared over 2 plus x, and again plus c. So I have my function, or a family of functions whose derivative would be 2x plus 1, but we want the specific function for which f of 2 equals 10. So I'm going to take my 10 and I'm going to replace f of x with 10. I'm going to replace x with 2, and then I will clean this up and I'll have c, and therefore I'll be able to write the exact function that satisfies all of that information. So we have 10 equals 4 plus 2, which is 6. If I subtract the 6 over, I get c equals 4. So my equation for my function, I want to find f of x, is going to be f of x equals x squared plus x plus 4. And here is the equation for which f of 2 equals 10. The derivative will then, when evaluated at 2, is 5. And then the derivative, the second derivative would simply be equal to 2. And so using information about the second derivative and or the first derivative, we can actually get back to and find some information about the original function. All right, so let's do another one. So, pardon me. Our next one is we have a second derivative, f double prime of x equals x to the negative 3/2. And in order for me to ultimately find f of x, I have to go through the channels of finding f prime of x. And to do that, I need to find the antiderivative of both sides of this equation. The antiderivative will be f prime of x equals, okay, when I add 1 to negative 3/2, that's going to give me x to the negative 1/2 divided by negative 1/2 is going to be the same thing as multiplying by negative 2. So I have negative 2x to the negative 1/2, and I have to add c. So here is the family of derivatives for which the second derivative is x to the negative 3/2. I have information now that will allow me to find c and get a specific first derivative. So I will replace f prime of x with 2. I will replace x with 4. And this will help me find c. So this is going to be 2 equals, this is going to be 2 over 4 to the 1/2 plus c. The square root of 4 is 2. This becomes negative 1, and if I add the 1 over, I get 3 equals c. So now my f prime of x has a specific equation of negative 2x to the negative 1/2 plus 3. So this is the equation that in which f prime of 4 equals 2. So now if I want to find f of x, I will find the antiderivative of the first derivative, which would be f of x equals, okay, I got to be careful here. Add 1, adding 1 to that power, adding 2 over 2 is going to give us x to the 1/2. If I divide by 1/2, that's the same thing as multiplying by 2. And then I will add 3x plus c. Okay, so now I'm going to take the information f of 0 equals 0 to find the specific function for which f of x is satisfied by f of 0 equals 0, which has a first derivative that is satisfied for f of prime of 4 equals 2, and then has a second derivative of x to the negative 3/2. Okay, so if x is 0, the result is 0. Well, I'm hoping that you guys can go ahead and see that our c value, oops, guess what I was supposed to substitute there? If I substitute 0 for x here and here, our c value turns out to be 0. So my equation for f of x will be negative 4x to the 1/2 plus 3x. If you take the derivative of this function, you would get negative 2x to the negative 1/2 plus 3. If you substitute 4 here, your result will be 2. And then if you find the derivative of this function, you end up with what we started with for the second derivative. Oops, I'm a little crooked, sorry. Okay, so that's going to, I'm going to stop with this particular this particular video. so that you can kind of digest what's going on and what we did up to this point. I'll then create the next video that will then work through some of the applications of antiderivatives. So, sorry to have taken that away from you. So, anyway, take a look at those, and once you feel confident, then let's watch the next video. See ya!